Hello and welcome to my talk, How to Scale Your Business in the Cloud in a Sustainable Way. My name is Nataliya. I'm Ukrainian, currently living in Stockholm, Sweden with my husband and two cats. I've been in the industry for quite a while now and currently leading platform engineering teams at PayPal within small merchants segment. Did you know that information communications and technology industry, which delivers internet, video, voice, and other cloud services, is responsible for up to 3.5% of global emissions? Worse still, these emissions are predicted to double by 2025. So how we as an industry can, if not reduce, to at least sustain the cloud resources wisely? So what is sustainability? In the broadest possible sense, sustainability refers to the ability of something to maintain or sustain itself over time. Currently, most cloud providers only provide basic calculations for energy or carbon emissions from cloud usage to their customers, typically in scope 1 and 2, as you can see in this picture, which can be a challenge for organizations who want to baseline and reduce their carbon footprint across all scopes. From the cloud consumer perspective, all the hyperscaler emissions fall under the category of your scope 3. As organizations align their businesses with sustainable practices, it is important to review every functional area. If you are building, deploying, or maintaining your product in the cloud, improving its environmental impact requires informed decision-making. The shared responsibility model for sustainability shows how it is a shared responsibility between cloud vendor, in this case it's AWS, and their customers. They're clearly stating that it's a customer responsibility of how we use services in the cloud, whilst the vendor is responsible for sustainability of the cloud. The sustainability pillar of AWS well-architected review provides the following design principles that can be easily applied for any cloud vendor of your choice. In this particular talk, I will use AWS for a reference and some examples. Let's look at them one by one in brief. It is important to understand and monitor your impact while building in the cloud. For example, over-provisioning resources can lead to unnecessary infrastructure cost, and under-provisioning resources can lead to poor application performance. AWS, in this case, recommend customers to use AWS Compute Optimizer service, which recommends optimal AWS resources for your workloads to reduce costs and improve performance by using machine learning to analyze historical utilization metrics. Let's look at the principle maximize utilization. One can maximize utilization by looking at which type of storage can best support how your data is accessed and stored to minimize the resource provisioned while supporting your workload. It is important to monitor your data access patterns and migrate data to the appropriate technology based on the access pattern. Migrate archival data to storage designed for that purpose. There are some improvements to look at when it comes to the data movement within the cloud. Always store data as close to the consumer as possible. Compress data before moving it over the network. Quite obvious, isn't it? Partition regionally consumed services so that their region-specific data is stored within the region where it is consumed. Use block-level duplication instead of file or object-level duplication when copying changes across the network. Reduce idle resources and maximize utilization. Use spot instances versus on-demand. Enable auto-scaling, which allows your workload to automatically scale up and down based on demand. For asynchronous workloads, use an event-driven serverless architecture so that compute is only used as needed and not in the idle state. Moving data across networks can contribute to energy consumption and your overall costs. Look at the solutions like AWS Direct Connect Cloud Service, which provides the shortest path to AWS resources. While in transit, your network traffic remains on the AWS global network and never touches the public internet. This reduces the chance of hitting bottlenecks or unexpected increases in latency. Managed services shift responsibility for maintaining high average utilization and sustainability optimization of the deployed hardware to the cloud vendor. Last but not the least, architect for sustainability. Event-driven architecture is common in modern applications built with microservices for designing serverless workloads. Event-driven architectures are push-based, so everything happens on demand as the event presents itself in the router. This way, you're not paying for continuous polling to check for an event. This means less network bandwidth consumption, less CPU utilization, less idle fleet capacity, and less TLS handshakes. I'd like to wrap up with the important message that literally everyone has a part to play in the climate solution. Sustainability is enough by itself to justify our work.
So the time is
Thank
out,
you.
Natalia. Thank you so much. Hi, we're from EFICO, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at efico.com and enjoy the inspiring talks at the DevOps conference.